Alright, so here's what happened. I recorded a 5-minute video demonstrating what we did in class on Wednesday, March 4th. And turns out I didn't have the microphone plugged in, so that was cool. I got the whole video, but I don't have any audio. So now what I'm going to do is I'm going to play the video and talk over it and see how close I can get to what I recorded before. So here we go. We are looking at trigonometry, but instead of describing trigonometry as just right triangles, we're going to describe trigonometry within the context of rotating around a unit circle. So we rotate around a central angle, and the radius of rotation is always going to be 1. That's why we call it a unit circle. So, for example, if I rotate 60 degrees, then we can start talking about trigonometry. How do we do that? Well, we form a right triangle by dropping from the point of intersection straight down to the x-axis. That forms a right triangle, and there's a 60-degree angle, and a hypotenuse is always 1. In fact, every right triangle on the unit circle to the x-axis will always have a hypotenuse of 1. There are infinite right triangles, all of whom have a hypotenuse of 1. What changes as we rotate is the length of the opposite leg, and that's the vertical leg. And also what changes is the length of the horizontal leg. That's adjacent to the angle. No matter where I rotate, both those legs are going to change their lengths. So to find the sine of 60, for example, all I have to do is measure the length of that vertical leg of the triangle. In other words, I just have to find the y-coordinate of the point on the unit circle that results after rotating 60 degrees. So in this case, the ruler is measuring 1 unit. The ruler is as long as the radius. So every centimeter on this ruler represents 1/10 of a unit. And if I look at this measurement, just measuring carefully, I notice that I have 8 centimeters plus a fraction more. So I'm going to say the sine of 60 has got to be around 0.87. 0.87 is my measurement for the sine based off of this picture. And the picture is imperfect. It's an estimate. But we go to the calculator. Make sure that we're in degree mode since we're doing 60 degrees in this case. And then we type in the sine of 60. I don't know what I was saying originally, but apparently it took me a while to get here. Sine of 60 equals. Boosh, 0.866. I guess 0.87. I'm really close to my estimate. It's almost as if I knew that answer already. And we do the same thing for the cosine now. The cosine, of course, measures the length of the adjacent side. In this case, that is the x point, the x-coordinate of the point on the circle. So however far from the origin horizontally I need to go, that will be the cosine of 60. And it appears on this ruler that it's 1/2. So if I type in the cosine of 60 on my calculator, I think I'm going to get 1/2. It says 5 centimeters, which is half of 10 centimeters, so it's 1/2. Cosine of 60, and that's the end of the school day. Cosine of 60 equals 0.5 is exactly right. Not even an estimate, so I feel really good about that result. So in class, we worked with the work on the top half of the slide. So we worked with everything in the upper half. And all of these measurements are in radians. That's why I went over here and turned the calculator into radian mode. And I'm going to look at the cosine of 4 to show you what we did in class. We did a competition to see who has the best measuring skills. And so to find the cosine of 4 without a calculator, I go back to my little cutout circle that we got on Monday, and I find a rotation, and get rid of this triangle. I find a rotation that represents 4 radians. There's 1 radian, that's the length of a radius stretched around the circle. There's 2 radians, there's 3 radians, and there's 4 radians. So to get the cosine of 4 radians, I just have to measure the x-coordinate that takes me to that point. And this triangle cuts and shows me that the 6 centimeters plus another half or so, so about 6.5. So I will estimate the cosine of 4 radians to be about negative 0.65. Notice negative because we are to the left of the origin horizontally. So the cosine of 4, negative 0.65. So I'm feeling really good about my abilities here. I'm going to do a few more for practice. So again, if you freeze the screen here, you can write down everything in the top half of this screen, and that should give you what we did in class on Wednesday. On Thursday, we're going to flip the script. On the bottom half of this screen, you see here, I give you ratios, that is lengths of sides of a triangle, and you have to tell me the corresponding angle in radians that would go with it. Turns out you can come up with sometimes more than one right answer. There should be at least 2 angles that will give you the same, and there's more, there's infinite, but you can come up with 2 angles that should give you the ratios that are shown here. So pause the screen, write it down, take out your little trig trainer, and off you go. Have a good day.